Alrighty, so for the next problem, what we're going to do is we're going to be given one trig function, and we're going to have to find the remaining one. So the way we're going to do this is we're going to have to know that the tangent of A is equal to some opposite side length divided by some adjacent side length. So in this case, if we don't have a value below it, we're just going to add 1. Right? 4 divided by 1 is the same thing as 4. So now we can go ahead and label our sides. So if angle A is where I'm looking at, then I know the opposite side is 4, and I know the adjacent side is 1. So I'm going to go ahead and use the Pythagorean theorem to get the hypotenuse, which would be the square root of 17. Now let's go ahead and find the rest of our trig functions. So we know that sine is going to be the opposite value, so 4 divided by the hypotenuse, so in this case 17. So I go ahead and rationalize that to get 4 radical 17 over 17. Cosine is going to be my adjacent value divided by my hypotenuse value. If I radicalize that, that'll give me 1 times the square root of 17 divided by 17. The next one is going to give me the, well, this one we already know, right? It's 4 over 1, opposite over adjacent. Now we just got to flip it. For cosecant, just flip the first sign, so square root of 17 over 4. Notice how I don't simplify the final answer. Then secant of A, just go ahead and flip the radical 17. So I just get radical 17 over 1, which is just equal to the square root of 17. And then I've got cotangent of A, which is equal to the opposite side divided by, sorry, cotangent is the reciprocal of opposite over adjacent, so it's adjacent over opposite. And there we go. Now we've got all 6 of our trig functions. So now I'm going to look at number 15. So we're using the law of sines and the law of cosines here. So we'll go over the formulas in just a second. So first, while I'm looking at this problem, the first thing I want to identify is what am I going to use, law of sine or law of cosine? One thing you should do first is you should find this remaining angle here at C. So I need to find this angle right here. We know the other two, so all we have to do is 180 minus, so angle C, we know is just going to be 180 minus whatever 70 plus 35 is. So 180 minus whatever 70 plus 35 is, and that's going to give me 75. Perfect, so that would equal to 75 degrees. All right, now that I have that angle done, now which formula can I use? I would recommend the law of sines, because it's the only one you could use. So we know that we have the sine of the angle. All right, so sine of, let's say, 75, since I'm given its opposite side, divided by its opposite side, 9, equals, now we've got to figure out what do we want to solve for. So let's go ahead and let's solve for, let's call this side here x. Right, let's solve for this side x. So I'm going to use sine of A. So sine of angle A, which is 35, we can use parentheses, so divided by its opposite side x. Now we're going to go ahead and just cross multiply. So cross multiply here, and we're going to get 9 times the sine of 35 is equal to x times the sine of 75 divide by the sine of 75 degrees on each side. And now we're good to go. So 9 times the sine of 35 divided by the sine of 75, and that should equal to 5.344. Those are 4s. Okay. 5.344. There we go. Okay, sounds good. So I found one side length here. I found this guy. Whoops. No. 5.344. Now let's go ahead and let's solve for this side over here. Let's put it in blue, let's solve for this side, y. So I'm looking to solve for this side. So same idea. Let's go ahead and create another ratio here. So I can use the sine of 75 over 9 again is equal to the sine of 70 over x. Now we're just going to go ahead and cross multiply. So then I'm going to get 9 times the sine of 70 equals, let's zoom in here, x times the sine of 75. Divide by the sine of 75. Go ahead and just plug that all into our calculator. So 9 times the sine of 70 divided by the sine of 75. And now I've got 8.755. Perfect. Now I've solved for every piece of the triangle. So now I know that this side is y is equal to 8.755. And there we go. Okay, so now I'm looking at number 22. These are just going to be like word problems. So let's go ahead and read this and see what we need to do. It says a lighthouse operator at a point 25 meters above sea level spots a sailboat out in the ocean. The angle of depression from his viewpoint is 10 degrees. How far is the sailboat from the lighthouse? So we have a lighthouse operator. So a lighthouse, we can think about like a little tower. This is not going to look great. So, but here he is up here. Here's the little lighthouse. All right, it's shining out. And so I'm assuming this person is up here. He's 25 meters above sea level. So I'll imagine that here's the sea somewhere down here. Okay. And it says that this person, he's up here, somewhere up here, spots a sailboat out in the ocean. The angle of depression from his viewpoint is 10 degrees. So let's just say his viewpoint is right here. This is him staring straight across. Now his angle of depression, so it's looking down, so he has to look down to look at the sailboat. It's going to be at an angle of 10 degrees. So this is an angle of 10 degrees. That's a degree symbol. It's really hard to draw. All right, 10 degrees, let's just say that. How far is the sailboat from the lighthouse? So I'm trying to find how far away it is. I'm looking for this value right here. How far is it? So if we were to make a right triangle out of this, right, I can make let's say the sailboat is out here somewhere. All right, the sailboat is like right here somewhere. So here's the right triangle. Now, if this side is 25, then I know that this side is also going to be 25 meters. So now we have a right triangle. We know that this side at the 25 meters over here is going to be opposite to the 10 degrees, right? That's opposite. We know that x is going to be the adjacent side. And we know this is going to be the hypotenuse. So now we've got to solve for x. So we're going to go ahead and we're going to create our trig function. So we're going to do, let's do it off to the side over here. We're going to do the sine, right? Tangent, sorry. We're going to do tangent because I'm given the opposite and I'm given the adjacent. So opposite over adjacent. And just like we typically do, cross multiply and solve for x. So 25 equals x times tangent of 10. Divide by the tangent of 10 on each side. and just plug that into your calculator. And I got 141.782. All right, so that makes sense because the man is only looking 10 degrees. 10 degrees is a really small angle measurement. So that means the boat would have to be pretty far. Okay, that looks good. Okay, so Eric and Zach are camping. Eric is going to leave Zach. So let's just say they're going to start right about here. Eric is going to leave Zach. He's going to walk away from Zach for about 4.5 miles. So he leaves for about 4.5 miles. Then he's going to turn 120 degrees, right? So if he's facing straight ahead, he's now going to turn 120 degrees. So that's going to be this angle right here. He's going to turn 120, and he's going to continue walking for about another 2.5 miles. So 2.5 miles. And then it's saying if Eric wants to take a more direct route back to the campsite, how far will he travel? So now we want to figure out, okay, how far does he need to travel to get back, right? We want to take a more direct route. He wants to go straight back. Okay, so look at the triangle that we've created here. Notice that this is going to be law of cosines, right? Because we don't have an angle on its opposite side. So we know that law of cosines is going to be, law of cosines is going to say that whatever side I'm trying to solve for is going to be equal to the other two sides squared. Whoops, C, not B again. So C squared minus 2 times those two sides times the cosine of whatever that angle is opposite to the side you're trying to solve for. So in this case, I'm trying to solve for side A. So I'm going to plug in the angle that goes with side A. So that is going to give me A, we don't know. So let's call this A over here. This is A. We have no idea what it is. So A squared is equal to, and let's go ahead and plug in the other two side lengths, right? B squared is going to be just one of the other side lengths. Let's call it 4.5. Plus C squared, which is my other side length, minus 2 times 4.5, just the other two side lengths, times 2.5, and then times the cosine of whatever my angle is that's opposite of the side I'm trying to solve for. So if I'm trying to solve for, if I'm trying to solve for side A, it goes with its opposite angle. So I'm going to plug in 120. And now we just plug this entire thing, or we plug just this entire expression into the calculator. So 4.5 squared plus 2.5 squared minus 2 times 4.5 times 2.5 times the cosine of 120. And we get 0.75. Go ahead and square root each side. So square root, and now I end up with A equals whatever the square root of 37.75 is. And I got 6.144. Okay, so what does it say? What's the question? If Eric wants to take more direct, how far will he walk? He'll have to walk 6.144 miles. My drawing doesn't show that accurately, right? So maybe that 120 is maybe not as is not that sharp of a turn, but that's okay.